Hello, everyone. Today, I'll be primarily talking about Databricks SQL Analytics, how it is different from traditional Databricks workspace, its architecture, and how security works in SQL Analytics. A little bit about myself. I am Don Bosco Durai. I am the CTO and co-founder of Privacera. At Privacera, we are doing security and governance in the cloud for the open data ecosystem. I'm also a PMC member and committed in the project Apache Ranger. Privacera is one of the preferred Databricks partners for security. I've been working with Databricks team for almost a few years now. We originally integrated Apache Ranger with Spark from Databricks, where we provided fine-grained access control for Spark and Spark SQL workloads. And when Databricks introduced Delta Lake, we extended our solution to transparently support Delta Lake also. So recently, when Databricks was working on SQL Analytics, we worked very closely with their team to design the necessary hooks to integrate Privacera seamlessly with SQL Analytics. Some of the things I'll be talking today are the outcome of our joint efforts. So let's start with personas and use cases. Broadly, there are two categories of users. One side is the business users who want to run queries and are looking for immediate response. And the other side, we have the data scientists and the data wranglers who want to run ML workloads or process gigabytes and terabytes of data. Previously, the same or the similar Databricks cluster were used for both the use cases. The business users could use Spark SQL, while the data scientists can use ML workflow and submit Spark jobs. But underlying, it was the same multi-node cluster running Apache Spark. Obviously, the Scala-based Spark is most suitable for batch processing. So what Databricks did was they introduced SQL Analytics, which is a ground-up redesign to specifically address the SQL queries. SQL Analytics uses a Delta Lake so that you don't have to move your data around, but still you can get the very high performance for BI queries. So we're going to be talking about security and compliance and privacy in the next two slides. So while SQL Analytics solved the problem of user experience for multiple personas, but it also introduced a new challenge. Now you have the same data set accessed by two different tools, by two different personas, but you still have to keep the same security and compliance policies consistent across both the tools. Also, now you have two different admins managing the policies. You have one set of admins managing the policies for the SQL Analytics using SQL grant and revokes. Then you have another set of admins managing the cluster policies, like the IAM roles for the cluster, the credential pass-throughs. So there's a possibility of inconsistency in the policies itself. Now, when it comes to security and privacy, there's another thing, right? Generally, security policies are confused with the privacy policies. In reality, there are two different policies mandated by two different groups. Like security policies are primarily about preventing unauthorized access to data. It ensures that users have access to only what they're supposed to have. And security is also responsible for encryption, but at a coarser grade. Example, disk or volume or bucket level encryption. However, privacy policy is all about how customer PII data is stored and used, and for what purpose. Data scientists and other users might have access to it, but they can only use them based on the consent provided by the customer. Also, there are privacy regulations that will restrict how you can use customer data. Example, let's assume you have some data set which contains race and gender, and you want to use it for credit scoring, but it is not allowed by compliance regulations. So you have to make sure that your data scientists and users are using the customer data or PII data particularly the way they have been given consent. Also, compliance regulation will add additional requirements, like you might have to encrypt all your PII and sensitive data, right? And who can see it? So you might have to store them in an encrypted form at rest, and in real time when you're accessing, you may or may not have, depending on the policy, you may have to decrypt it. So all these different things can lead to governance blind spot, because the privacy team will have their own set of requirements, which is based on state and country and industry regulations. The security team, who is responsible for unauthorized access, they will have their own set of policies. they are trying to prevent data leakage, and they have encryption policies. The owner of the data will have their own concerns. They want to make sure who's using the data for what purpose. So when you start adding all of them, you want to make sure that you're not overriding each other's policy and also managing them more holistically across different systems and tools. Auditing is another challenging part. With so many different systems and logging mechanisms, it's very difficult to keep track who's accessing the data and for what purpose. So you should try as much as possible to centralize the audits to one location. This includes both SQL access as well as accessing file and objects. And there are a lot of advantages if you're able to centralize the audits. First of all, you'll be able to see all the access logs in one place, who's accessing what. Then you can generate different reports based on different requirements. You may have compliance team, they have their own set of requirements. You will have the governance team, you have the data owners. They all will have different expectations or want to see different things in the report. And you may have a security team who may want to have alerting in real time. And if you're doing classification, like you're tagging your data, then you can actually use this audit records to mix it and generate more actionable reports, like who's accessing your PI data, for which system, and for what purpose. So now let's see how we can address this thing, right? We'll start with the Databricks native support for security. So Databricks has a pretty rich set of security features. For data, you can have user credential pass-through, you can have IAM roles, and you can also have grant and revoke for Spark SQL. We'll talk a little bit about that. With IAM roles for the cluster, the IAM roles are associated with the EC2 instances where the Databricks driver and the executors are running, right? So anyone who has access to the cluster at the same level of permissions. With user credential pass-through, you can now apply IAM role at the user level. So if you have multiple users using the same cluster, and each could have their own IAM role. So in that way, you can control what the user can access. But there's some little downside of the IAM role, because IAM role, you have to set up the policies within a JSON file and a JSON blob, which can be maximum 20 KB. So you can limit how much they can access, but you still have some options about it. But if you need more fine-grained permissions, then you can use Spark SQL, and which provides table-level access control. And additionally, for clusters, you can have cluster policies. With this, you can allow any users to create a cluster, but limit what IAM role they can associate the cluster with. Database also supports permissions at the cluster level. So you can decide who can start the cluster and stop the cluster. And it also has permissions at the notebook level. So let us see what Privacera has done and how we extended Databricks to address it. So what we have done is we took Databricks core security and we built on top of it, right, to address some of the complex enterprise security and compliance use cases. And at the same time, we also made it easier to manage the policies and be consistent across all use cases and tools. While in the Databricks, you had to run grant and revoke on the SQL. Since we're using Apache Ranger in Privacera, you have REST API, you have user interface to manage the policies. And since we're using Apache Ranger as the foundation, you will also get all the security features that Ranger supports. That this includes centralized policy management. You have also centralized collection of audits. And since Ranger has been built with big data in mind, it is very scalable. You can support hundreds and thousands of nodes in database without affecting the performance. So in traditional database, Privacera supported fine-grained access control at various levels. Like if you take SQL, we could support database, table, and column level access control. And we could also support dynamic row level filtering. Example, if you have two users running the same query against the same table, they will get different results based on their permission and what purpose they're using the data for. Similarly, we could do column masking in SQL. Well, certain sensitive columns can be automatically masked on what the users are allowed to see and in what format. And we also support dynamic decryption. Let's assume you have, for security or compliance reason, you want to have your PII and sensitive data stored in an encrypted form at disk. So when you are trying to run the query, you're going to get encrypted data. So with Privacera along with Ranger, you can decrypt them dynamically based on the access policies. And the data is also encrypted using the key is stored in Ranger KMS, so you get the benefit of both access control on the data side as well as access control who has access to the key. In ML workflows, we can also support object and file level access control. This is for both reading and writing. And since the policies are defined in Ranger, very similar to the HDFS, you can give at any level. You can give at a file level, or you can give at a folder level. You can have tag-based policies and other ways of managing the policies also. And similarly, Ranger supports attribute-based access control, role-based access control, tag-based policies. All these features also comes for free. When with all these low-level features, now without copying or moving data, you can now very easily implement consistent policies for GDPR, CCPA, and other compliance regulations across multiple tools and data sources. So without going too much depth, at the high level, Privacera is based on Ranger. So in the traditional clusters, the Ranger plugins are embedded within the Spark driver itself. So it makes the access decision who can access what resources and in what format they can see it. And it also collects all the audit records and sends it to a central location. Now, since the plugins are running within the process, within the same process, not as a separate process, it is super efficient, right? So what happens is when you're running the query or when you're trying to access a file, so do a very quick check whether the user has a permission to the table or the columns or the objects the user is trying to access, and also whether a masking has to be applied or the row level filter predicate has to be applied. And if it has to be applied, to sort of rewrite the query at the fly. And once the check is done and the user has a permission, the Ranger plugin gets out of the way and let Spark do the rest of the thing. So Spark will then send this request to multiple executors to read and write. And those executors will use the underlying IAM role, if required, to read the write from the S3 and ADLS. So there's absolutely no performance overhead. Now let's see how we integrated with SQL Analytics. So for SQL Analytics, we work very closely with the Databricks team to provide the same security feature as in traditional workspaces. That is, you can do table and column level access control, like a tag-based policies and attribute-based policies, dynamic loader filter, and also dynamic masking. But we also took it a step further. So we did a first-class integration with Privacera Cloud, which is our SaaS offering. With this integration, there's no need to deploy Ranger or even embed Ranger plugins within the Databricks. Instead, what we did was we embedded Ranger plugin within our own policy sync process, which runs in the cloud, in our cloud. So you still define the policies in Ranger, which is hosted in our cloud, and policy sync will automatically translate them into grant and revokes in SQL Analytics. So the policies are enforced in real time by Databricks SQL Analytics. And since the data is not going through any proxy and there's no other external influence, there's absolutely no performance overhead. So now, regardless who's accessing the data, how are they accessing, which tool they're accessing, the policies are consistently applied across the board. So I'll be showing that in my demo. So to summarize, to get with this integration, you get fine-grained access control at row and column levels. You have a single pane visibility of data across multiple cloud services in SQL Analytics. You also get real-time monitoring of all audit trails, and you can use all of them to comply industry and privacy regulation like GDPR, CCPA, HIPAA, and NGPD. So now we'll go to the demo.
So here I have three different services running. I have the Privacera portal out here running out here. So the Privacera portal is where you're going to centrally manage all the policies. We support almost all the cloud services, whether it's going to be Trino, Presto, S3, or Athena, Redshift, ADLS, Snowflake, even Google BigQuery. So you're going to manage the policies in one place, very similar to Ranger. Then I have a traditional Databricks cluster, and I have a notebook. And then I have got one more service. That's this endpoint. That's this SQL Analytics. And what I'm going to do for this demo is going to be using a single user called Emily. And also to keep it simple, we're going to be only using one database and one table. But what I'm going to do is I'm going to be changing the policies for Emily or for the role Emily belongs to. And I'm going to run it both on the database cluster as well as on the SQL Analytics. Okay, so just get started. So let me go to Privacera, and I'm going to just show the first policy. So I have a database table, sales data, and I have star, which means all the columns in this particular table. And I'm giving the role, sales role, the select permission. Now Emily belongs to the sales role. So when Emily runs this query, select star from that table, she will get pretty much all the rows and columns from this table. If I go to SQL Analytics and if I run the same query in SQL Analytics, and I should get the same results. So I'm getting the same result by country, region, city, name, sales amount, and I'm getting all the rows out here. Okay. So now what I'm going to do first is I'm going to go and disable this policy. Okay. Now with this policy, Emily should not have permission to run the query. So if she comes into the database cluster and she tries to run the query, she should get a authorization failure. That is, Emily does not have the permission to do select query on this particular database and table. And if she tries to run the same query from SQL Analytics, she will be rejected. Right? You'll see one difference between the database cluster as well as in the SQL Analytics. The error messages are slightly different because in the SQL Analytics, the SQL Analytics is actually enforcing it, so the error messages are much more native to it. While on the case of Databricks cluster, it is done by the Ranger plugin from Privacera, so it's a slightly different message. There are going to be some other changes also. I'm going to be telling you guys as we go forward. Now what I'm going to do is I'm going to enable one more policy where the same table, but I'm going to give column level access control. So here I'm going to just give to the 4 columns. I will not give the permission to the column name, but in this time I'm just going to give it to the user Emily. Okay, and I'm going to save the policy. Now if I go to the database cluster and if I run another query where I give explicitly the 4 columns Emily has permission to, so this query should go through and she should be able to see the 4 columns. And if I come and run the same query in SQL Analytics, I should see the 4 columns, but since Emily does not have access to the column name, it will be redacted. But the rest of the data should be identical between SQL Analytics and the database cluster. Okay. Now if you see out here, Emily can see the rows from all the countries and she can see the values for all of them. So what I do is I will enable masking policy in Privacera and particularly for the column city and see what happens. So we're going back to Privacera, we'll go to the masking policy and I'm going to enable this policy. Same table, but I'm using the column city. And what I'm trying to do out here is for the role which Emily belongs to, I'm going to set the hash policy, where you can have different sort of masking policies, including your own custom. But I'm going to just use out of the box hash for the time being. So I'm going to save this thing. And if I come and run the same query again for the same database and table, what you'll see out here is I will see all the 4 columns, but the city is going to be hashed out. So Emily cannot see which city the user belongs to, how this sale is made. And if she comes and runs the same query out here in SQL Analytics, she'll pretty much get the same result where the city will be hashed out. I'll go back to this and say, I'm going to do a rollover filter. In the rollover filter, what happens is, in this particular use case, for this particular table, I'm going to say that this role only has access to the records from the country UK. Okay, so I'm going to enable this policy. And since I enable this policy, if I come and run the same query again, and what you'll see is Emily can now only see the data from the country UK. And the same behavior she'll also see in the SQL Analytics if she runs the query again. So you'll see that the results are filtered out. Now, if you notice one thing, that regardless which tools she used, the output is consistent between both of them, right? And also, a lot of things are happening dynamically behind the scene. So even though she's running the query against the same table, the result set changes based on what permission she has, right? So if you are going into compliance requirement where you are having a GDPR requirement where you can only see data for a given country, or you cannot see data for users who are not given consent, you can automatically filter it out based on what user and what purpose they're trying to run. Similarly, if you have some data science use cases where you don't want to show the clear data, you can actually also go and mask it out. Okay. And just to wrap this up, if I go to the audits, I will see the audits from both the Spark, which is the Spark SQL, as well as from the SQL Analytics, just because they're coming from two different sources. In one place we show the full email ID, while another is only thing, but this is more of a technical thing, probably eventually will normalize the users also. Yeah. So that is all from my side. So we'll open up for questions.
I hope this session was useful for you. Please free to contact me via LinkedIn, and also don't hesitate to try out Privacera Cloud for free. Thank you very much.